right? An important application of a series circuit is what we call voltage divider circuit. Voltage divider circuit. So as the name implies, we'll be looking to divide a voltage, and this is useful when you have a source, let's say of a certain voltage, and you have a device that you're trying to power from that voltage source, but the two do not match. So let's say you have a battery, okay, so you have a battery given to you, okay, that's the positive terminal, that's the negative terminal, and it's rated for 6 volt, and you have a device, okay, whatever it may look like, let's say that's the device, and device is rated only for 3 volt, okay. So now the question is, how can you power a 3 volt device from a 6 volt battery? Well, you can put together a series circuit to get a 3 volt effective output. So for example, you have your battery over here, which is 6 volt, and you can take two resistors, okay, take two resistors, let's say R1 and R2, and we can choose the values of the effect of the R1 and R2 such that the voltage at the output, and let's say the output is in this case is defined as the output here, okay. So I'm going to measure my voltage across A and B. All right, and this is where I will essentially be connecting, my device. So this is where I will be connecting my device. Okay, so now the question is, what is VA minus VB? If I can get my VA minus VB to match with the voltage of my device, so that's 3 volt, then I can do this, right? So one easy way to do this in this case, of course, would be to basically pick two resistors which are of equal value, because if I do that, then I know because R1 and R2 are in series, the voltage would be equally divided between the two. So I could make this to be, I don't know, let's say 1000 ohm, and make this to be 1000 ohm, right? And I would basically divide the voltage. So let's look at it and see how we can get any voltage range that we want, right? So first of all, for this circuit, we know that, let's say this is no longer 6 volts, this is V, this is R1 and R2, then we know that V is equal to I times, so the I being the current coming from the source, equal to the effective resistance, which is R1 plus R2, which I can write because R1 and R2 are in series. So I get I equal to V over R1 plus R2, and I can now write the voltage drop across R2, which is VA minus VB, and that would be equal to the current flowing through it, which is V over R1 plus R2 times the resistance value, which is R2. So that gives me V equal to, V minus V equal to V times R2 divided by R1 plus R2. So by picking this ratio correctly, I can get whatever voltage I want. So if I want half the voltage, then I have to make sure that this ratio over here is equal to 1 by 2. So R2 divided by R1 plus R2 should be equal to 1 by 2. And that gives me R1 plus R2 equal to 2R2. And that means R1 equal to R2. And that will give me half the voltage. On the other hand, if I was looking for 1/3 of the voltage, then this would change to 1 over 3. And again, I would have to find what that ratio would be. So, one of the ways you can write this is V times 1 over R1 over R2 plus 1, right? So now all I have to do is pick this ratio correctly to get whatever desired voltage I want on the output. Another application of a voltage divider circuit would come when you start to put together different kinds of sensors in your circuit. Now, some of the sensors like photocell basically are nothing but variable resistors. They act like variable resistors. So if more light falls on a photocell, then its resistance value essentially drops. So you can detect the presence of more or less light by measuring the voltage across the photocell. Okay, so as less light falls on it, its resistance value will increase, and resultingly its voltage is going to increase as well. Okay, so you would essentially replace something like R2 with a variable resistor. So let's see what happens when we do that. So I have V over here, I have R1 over here, and then here I will have R variable. Okay, R variable. So if I have R variable, then I know that first of all the current is equal to V divided by R1 plus R variable. Okay, and that means voltage drop across A and B. So this is where I'm tapping. So VA minus VB is equal to V divided by R1 plus R variable, and that is times R variable. So that is equal to V times 1 over R1 over R variable plus 1, right? So by measuring this is V minus VB equal to this. By measuring as to what the voltage across A and B is, what this is, I can tell something about the variable resistance. And by noticing how that voltage is changing, I can predict basically what kind of physical phenomena may be happening, right? Because I know that if this is a photocell, then if more lights fall on it, then its resistance value is going to go down. If the resistance value goes down, then the voltage drop across this is going to also go down. And that means by measuring that voltage drop, I can tell that there's more light falling on the photocell. Okay. You can also use the same setup where our variable could be, instead of a photocell, could be a potentiometer, could be a variable resistor like a sliding one or a rotary one, and that would give you basically more control over what the output voltage would be. So as opposed to using a fixed resistor over here, you could always have a potentiometer and change the effective voltage across A and B on the fly. One last concept before we wrap up this particular video is the concept of the ground. So the concept of ground. Often in electrical circuits, we will talk about a particular point being at a certain ground voltage. So what does that mean? So often you will see that we will draw something like this. I will have my battery, I'll have my resistor, and maybe other elements, and then I will show something like this. Okay, and this symbol over here is for ground. Now remember, for the voltages, it is not meaningful to talk about the voltage at a certain point in the circuit unless you can define what the reference point is, right? And that's the reason why we always talk about the voltage difference. We never say V equal to something. We always say V at some point minus V at some point equal to, I equal to R. So instead of worrying about what that reference point is, we basically make that reference point to be basically as a ground or a zero voltage point. Okay, we make it a zero voltage point, and that way we can say that, okay, if this is point A, this is point B, then since VB is nothing but V at the ground, that's zero, VA minus VB is nothing but basically VA. Okay, because VB is zero, or this could be equal to the voltage. So there are different ways we will show the ground, but wherever a ground is shown, you can assume that the voltage over there is zero. So there are certain times when this circuit may be drawn like this. Okay, so I may draw the resistor like that, and I will show this is at ground, and then I have my resistance, and I will draw this as a ground over here too. And this is a complete circuit too, because this is the ground and this is the ground, and of course those two, even though it's not clear over here, are connected with each other, right? So you have to have a complete circuit for the electrons to flow and come back, otherwise it's an open circuit and no current can flow through that. So this circuit over here is completely equivalent to the circuit